Imagine stumbling upon a cosmic giant so massive that it defies comprehension. A black hole weighing in at an astonishing 36 billion times the mass of our sun. This isn't science fiction. It's one of the largest black holes ever discovered, nestled within the heart of the cosmic Horseshoe galaxy system. What makes this discovery even more mind-blowing is how scientists managed to spot it through a dazzling phenomenon known as an Einstein ring, a gravitational lens created when a colossal object warps space-time and magnifies the light from objects behind it. But here's where things get even more intriguing. This black hole might not even be the biggest out there. The research, published on August 7th in the monthly notices of the Royal Astronomical Society, dives into the details of this ultra-massive black hole. Scientists can't directly observe black holes because they emit no light. Instead, they rely on indirect clues like radiation or how nearby objects behave. Using advanced models, researchers estimate the size of these enigmatic giants. However, these models come with uncertainties, especially when studying distant young black holes. As astrophysicist Thomas Connor from the Center for Astrophysics at Harvard and Smithsonian explains, while this black hole ranks among the largest known, it may not hold the top spot. In fact, another contender, TON 618, could outweigh it by several billion solar masses, clocking in at roughly 40 billion times the mass of the sun. But why does size matter so much? For astronomers, these gargantuan black holes aren't just record breakers. They're puzzles begging to be solved. Their existence challenges what we think we know about the early universe. Most large galaxies are believed to harbor supermassive black holes at their cores, suggesting a deep connection between galaxies and their central black holes. Yet questions remain. Do galaxies and black holes evolve together? Or do black holes sometimes race ahead in growth? And how did these monstrous entities form so quickly after the Big Bang? Enter observatories like the James Webb Space Telescope, JWST, which have begun spotting ultra-massive black holes in the distant reaches of the universe. These findings raise eyebrows because they suggest that some black holes grew to unimaginable sizes in surprisingly short periods. To put this into perspective, imagine walking into a daycare center and finding a toddler who already towers over adults, someone like LeBron James at age 3. That's essentially what scientists are grappling with when they find such massive black holes in relatively young galaxies. It's theoretically and computationally incredibly challenging, Connor notes, highlighting the ongoing mystery surrounding their rapid growth. One hypothesis suggests that black holes and their host galaxies experience intense growth spurts early on, consuming vast amounts of material before settling into long periods of dormancy. But this idea pushes against fundamental limits on how fast objects in the universe can grow. Could dark matter play a role in accelerating this process? Or are there other forces at work that we don't yet understand? These are the kinds of tantalizing questions driving current research. Interestingly, the detection of the cosmic Horseshoe's black hole was partly serendipitous, relying on a combination of stellar motions and gravitational lensing. But this method has its limitations. Not all massive galaxies align perfectly for lensing to occur, meaning countless others with equally impressive black holes might remain hidden from view. Are there massive galaxies out there that we need to find new ways to measure? Connor wonders aloud. His question leaves us pondering whether our current tools are sufficient to uncover the full scope of these cosmic behemoths. So what do you think? Are black holes the ultimate architects of the universe, shaping galaxies far beyond what we currently grasp? Or is there something else entirely at play that we've yet to discover? Share your thoughts in the comments below. Let's spark a conversation about the mysteries lurking in the depths of space.